Hi. So today we want to talk about the mathematical interpretation of the word of when it is used in a phrase such as this one. So let's begin with looking at a situation where you have a whole number of another whole number. So in other words, if I have say 2 of 10, or in other words, let's say I have $10 notes, two of those $10 notes, one in one hand, the other in one hand. So really, two copies of 10 can be abbreviated sometimes as 2 of 10. So 2 of 10 really means two copies of 10. And when we have that understanding, it's really easy to now compute what 2 of 10 is, a $10 note and another $10 notes. That is 10 plus 10, which is 20. So here the understanding or interpretation of helped us compute 2 of 10 as 20. Now let's look at this 10 of 1/2. So say you have a jar which contains half a gallon of water, and we have 10 of those half-gallon containers. So how much total water do we have? Well, we interpret that as, well, we have half gallon and another half gallon, half plus half plus half. How many? 10 of those. And you'll very easily be able to figure out that 10, when you add half to itself 10 number of times, by now you know that's really 5. So in these situations, of really meant copies of. When you have a whole number here, that's how we interpreted it. Whatever you have here, we add it to itself, that whatever whole number times you see out there. Now let's go back to something like this, 1/3 of 4/5. So if you say here too, I would like 1/3 of 4/5 to mean 1/3 copies of 4/5, just like in these situations, then you'll have to really explain what do you mean by 1/3 copies of 4/5. Because at this time, for us, copies of something means we take the same thing and it is whole number counting of that same thing that many times. So here it was 10 plus 10. Here it's half plus half plus half, 10 number of times. So now we need to really explain what do we mean by 1/3 of 4/5. Even if you say it means 1/3 copy of 4/5, we need to explain what does that copy of mean. So that's what I'm going to attempt to do next on the other board. And once we have a precise definition for 1/3 of 4/5, we will be able to actually compute what 1/3 of 4/5 is as a number, just like these situations. So here's the precise definition of 1/3 of 4/5. 1/3 of 4/5 is the length of one part when the segment from 0 to 4/5 is partitioned into 3 equal parts. So it becomes important for us to figure out how to look at this segment and partition it into 3 equal parts. So let's do that now. So we notice that this segment is made up of 4 copies of pieces that are of length 1/5. Since 4 is not a multiple of 3, we have to do a little more work in order to divide this segment into 3 equal parts. And here's how we'll proceed, and we've done this in other videos too. So we'll look at this piece and partition this into 3 equal pieces. We'll go ahead and do the same for each of these pieces that's of length 1/5. Now what do we have? We can look at this segment and view it as a concatenation of 3 times 4 of these short pieces. And 1/3 of 3 times 4 is 4. And so if we would like to divide this into 3 equal parts or 3 equal groups, we simply need to take 4 pieces and 4 of these short pieces, concatenate them and put them into one group. So let's proceed as follows. So 1, 2, 3, 4. So here's my first part. Then here's my second part, which consists of 1, 2, 3, 4. 4 of those short pieces. And finally, here's my 1/3 part. 1, 2, 3, 4. 4 of the short pieces. So by subdividing each of these into 3 equal parts, I've now successfully used that idea to partition this segment into 3 equal parts. So by definition, 1/3 of 4/5 is really the length of this part. What is that length? Let's find that out now. So we notice this segment, whose length we're interested in, is 4 copies of segments of this size. So we really want to know what is the length of such a segment. To see that, it would be easiest to go ahead and partition this last fifth also into 3 equal pieces. Now what we notice is the unit segment is now being partitioned into 3 times 5 number of pieces. Originally we had partitioned the unit segment into 5 equal pieces, and now each of those fifth of a piece is now partitioned into 3 equal pieces. So overall, this unit segment is now partitioned into 3 times 5 pieces. And so the length of one such piece, this piece, is really 1/3 times 5. And you'll see in a minute why I'm not writing 1/15. You can if you like, but I'm going to leave it as 1/3 times 5. Now we remember we're interested in this piece length because 1/3 of 4/5 is the length of this piece. Well, this piece is the concatenation of 4 such pieces. So this piece's length would then be, so this piece is really 4 copies of 1/3 times 5. So in other words, it is 4/3 times 5. Now certainly we can simplify this expression to get 4/15 and conclude that's the answer to 1/3 of 4/5. We can conclude 1/3 of 4/5 is 4/15. However, before I write that, I'd like you to pay attention to the following. I'm going to rewrite this fraction as follows. The numerator 4, I'm going to rewrite it as 1 times 4, and you'll see in a minute why I want to do that. Okay. So 1/3 of 4/5 by definition is the length of this part, and which with our reasoning we concluded that it is the fraction 1 times 4/3 times 5. So 1/3 of 4/5 is this fraction whose numerator is simply the product of these two numerators, and whose denominator we observe is really the product of these two denominators. So keep that pattern in mind, since I'm preparing you for the general formula of a fraction of a fraction. And now if you like, you can go ahead and write, simplify this as 4/15. So in the next video, we'll discuss 2/3 of 4/5 in great detail. Thank you.